Okay, so this video is a continuation from the counter video. And in the counter video we looked at sketching out the code and handwriting out the code, and now I just want to show you it within the TIA portal itself. Now I'm not going to show you the longhand way of doing the code. I think that's fairly straightforward. We're just going to show you how to implement the counter. So let's say we looked and count a plus, a minus, and do that 5 times. Okay, so what we're going to do is we're in our main sequence block here, main sequence. So we're going to go ahead and start ourselves off. So we're going to go data block, dot position, when we're in 0, and we're just going to wait for someone to press a start button, start PB, and that will go ahead and move us into step 10. Okay, step 10 for the data block. Now what we would do then, go back into our main OB1, we would have an output here for a extend, and we would have equal to step 10. We would want our A to extend. Go back into our main sequence. We can copy this down. We can say in step 10, A is extending, and we know when we finish that, when we hit AL1 to move us into step 20. So then in step 20, we need to go back into our OB1, and in step 20, we are going to go ahead and make a retract. Okay, back into our main sequence, and what we need to do is copy and paste this line again. I would say in step 20 we know A is retracting, so how do we know when we finish that step? Well, we'd hit AL0. Okay, so essentially if we were looking to do this the long way, we would copy these 2 lines out another 4 times, so it'd be another 8 lines of code, so 4 pairs, and that would still do the same thing for us. But what I would like to do is put in a counter. Okay, so I'm going to add in a new network in here, and we're going to add in our counter. Okay, so again, it'll ask us to give us a name. We got to give a unique name for every single counter or timer we use. So this is a counter. It's in my main block, and it's the first one I'm using it. So counter M1, and I want this to count to 5. Okay, and what I'm looking to do is I want this to count only in step 10. So remember, these 2 networks will happen at the same time because they're both in step 10. They will both hit A1, and it'll put a count in, and then it'll move me to step 20. Okay, so I want to count A1 when I'm in step 10, but my output will be a memory bit. Okay, so I've got to create that. In my PLC tags, you'll see I have a memory folder here, and what we'll just call it is count reached, and it's got to be a percentage %M. So you got to make sure always with these tag tables to default to %I. So you got to make sure it's a %M. Otherwise, it'll be expecting you to hardwire something into it. It's an internal memory bit. Call them internal registers or markers or flags. You might hear me call them. So I can now use that as an internal memory bit to keep track if my count is reached or not. So once I get 5, it will go ahead and turn on that output. So then what I need to do is I need to query this at the end. I need to say, copy this down, I need to say in step 30, I'm either going to go ahead and move back to step 10, or I'm going to put another branch in here, and I'm going to move to 40. So essentially what we're saying is we're going to say if the count is, sorry, that's the wrong way around. If the count is not reached, so if we haven't finished counting, we're going to go back to 10 and repeat this sort of 3 lines of code again. And if we have reached our count, then we're done with everything. So we need, if we have reached our count, then we're done with kind of recycling through these lines of code, and we can move on to step 40, and you know, we'd have sort of a line of code there in step 40, something else would happen, and it would move us to step 50, and we continue on whatever we need to do. And that will help keep us cycling through until we do 5 times, and we need to just sort out a reset of our counter so that this can happen again multiply in multiple circumstances. So we always want to do sort of two ways of resetting our counter, usually a manual way and an automatic way. So the manual way is just usually with a reset PB or stop push button or something like that. And then here what we actually want is we want an equal to symbol. So I'll just copy that down, it'd be as easy. So we're going to say in a particular step number in the sequence, I want to automatically reset this counter, and we're going to use step 40. So once we come into this point in the code, we're done with all our counting and going back and forth and up and down that code, so I can use that to reset my counter. And that essentially would be all the code that you would need for that. You're just starting your sequence, you've put in your counter, making sure you use your counter bit. If you reset an automatic way and a manual way, you're using the integer to only count this input at this moment in time, at this step number. You have the pairing that will go through, and then you have the query to say, has the count been reached? No, okay, go back and do it again. If it has, continue on down the line and reset your counter. And on the inputs, in the outputs, it's fairly straightforward. 10 and 20 will activate them, and as the main bit of code moves us back to step 10, it will repeat the extension, and moves us back to step 20, that will repeat the retraction, and that will happen 5 times. So hopefully that all makes sense. Don't forget about your memory table. It's got to be %m, and you can give it a particular name. If you're using multiple of these, you might want to give it a better name.